Good morning. We continue with the oxidation of aldehydes. Next is oxidation with benedict solution. Third one. Oxidation with benedict solution. Benedict solution is an alkaline solution of cupric ion complex with citrate ions like filling solution. What is filling solution? Filling solution is alkaline solution of cupric ion complex with tartrate ions. Here in benedict solution is alkaline solution of cupric ions complex with citrate ions. So alkaline solution of cupric ions complex with citrate ions. Okay, citrate ions. And benedict solution is prepared from crystalline copper sulfate, sodium citrate, and sodium carbonate. So benedict solution is prepared from crystalline copper sulfate, sodium citrate, and sodium carbonate. Okay, sodium carbonate. Now you can see that when aldehyde, both aliphatic and aromatic aldehyde is treated with benedict solution, the aliphatic aldehyde or aromatic aldehyde will be oxidized to the corresponding carboxylate ion or carboxylic acid. At the same time, benedict solution is reduced to red-brown cuprous oxide. So look at it here. When aldehyde RCHO is treated with this is aliphatic aldehyde or aromatic aldehyde is treated with benedict solution, it can be represented by Cu2 plus 5OH minus. This is benedict solution. Okay. So what will happen? As we have discussed in the previous cases with the tolerance reagent or filling solution, the aldehyde RCHO will be oxidized to the corresponding acid RCOH. At the same time, this benedict solution, this will be reduced to cuprous oxide Cu2O, and we get red-brown PPT. So both aliphatic aldehyde and aromatic aldehyde can be oxidized with benedict solution. Both aliphatic and aromatic aldehyde will be oxidized to the corresponding carboxylic acid. At the same time, benedict solution will be reduced to red-brown precipitate of cuprous oxide. If you take a ketone, no reaction, or you can see that no red-brown PPT. This is another test to distinguish between aldehyde and ketone. So oxidation with the benedict solution. Okay. And the last one, oxidation with bromine water. Fourth one. Oxidation with bromine water. Aromatic or aliphatic aldehydes can be oxidized with bromine water. So bromine water can oxidize aldehyde into the corresponding carboxylic acid, and you can see that during this reaction there is a decolorization of bromine water is taking place. Bromine water is decolorized, or you can see that the bromine water is reduced to hydrogen bromide. Look at here. When aldehyde RCHO is oxidized with the bromine water, Br2 plus H2O, warm. What will happen? The aldehyde will be oxidized to the corresponding acid. You get RCO H corresponding carboxylic acid. Simultaneously, actually bromine water is having a pale pink color. The pink color is disappearing due to the conversion of bromine into reduction of bromine into hydrogen bromide HBr. So you can see that during this reaction, bromine water decolorizes. Okay, and if you take ketone with the bromine water, ketone with Br2 plus H2O, no reaction. That means if you allow to react ketone with the bromine water, that pale pink color of the bromine water persists. It won't disappear because the oxidation reduction is not taking place if we take a ketone. So this test also can be used for to distinguish between aldehydes and ketones. Aldehydes can decolorize bromine water. Because during this reaction, bromine water is reduced to HBr. Therefore, there is a decolorization of bromine water is taking place. While ketones cannot reduce bromine water. Therefore, the pale pink color persists. Okay, so this is another test to distinguish between aldehyde and ketone. Aldehyde decolorizes bromine water. Ketones do not. Okay, so that's all about oxidation reactions of aldehydes and ketones. Next is acidity of alpha hydrogen atom in carbonyl compounds. This is another important point. Acidity of alpha hydrogens in carbonyl compounds. Acidity of alpha hydrogens in carbonyl compounds, or another heading we can write enolate ion formation. Enolate ion formation. Look at it here. This is important. Enolate ion formation. Acidity of alpha hydrogen atom in carbonyl compound. What is mean by alpha hydrogen atom in carbonyl compound? If you take acetaldehyde CH3CHO, what is the actual structure? CH3, C double bond OH. Okay, so this is carbonyl group. This carbonyl group attached to carbon. This carbon is alpha carbon. This is carbonyl group. CO group is carbonyl group, and the carbonyl group attached to carbon is known as alpha carbon, and the hydrogen atoms present on this alpha carbon, these are alpha hydrogen. This is alpha hydrogen, this is alpha hydrogen, and this is also alpha hydrogen. Another example, acetone CH3, C double bond O, CH3. Okay, what is the actual structure? CH3, C double bond O, CH3, CH. So a carbonyl group attached this carbon, alpha carbon. This is also alpha carbon. This is alpha hydrogen. These are also alpha hydrogen. Now, what is our heading? Acidity of alpha hydrogen atom in carbonyl compound. What is the meaning of that? What do you mean by acidity of alpha hydrogen? We can see that this alpha hydrogen. What do you mean by alpha hydrogen? Carbonyl group attached to carbon is alpha carbon. The hydrogen atoms present on this alpha carbon atoms are known as alpha hydrogen. These alpha hydrogen atoms are more acidic. What do you mean by more acidic? Yeah, that means this hydrogen atom can be immediately donated to a base. This hydrogen atom can be immediately donated to a base. If a base comes to aldehyde or ketone, these hydrogen atoms can be removed in the form of a proton, or the base can easily remove. If a base comes easily, it can easily remove this alpha hydrogen atom. What is the reason for that? That means these alpha hydrogen atoms are more acidic than other normal hydrogen atoms present in sp3 hybridized carbon atoms. So what is the meaning of that? If you take CH3, if you take ethane, CH3, okay, CH. So this is what is this one? CH3, CH3. But you can see that these hydrogen atoms are more acidic than the normal hydrogen atom, than these hydrogen atoms. Okay, these hydrogen atoms. What is the reason? Why? Similarly, you can see that these three hydrogen and these hydrogen atom can easily removed by a base. But these hydrogen atoms cannot be removed by a base. That means the alpha hydrogen atoms present in a carbonyl compound. The alpha hydrogen atoms present in a carbonyl compound are more acidic than the normal hydrogen atoms present in sp3 hybridized compound. sp3 hybridized compound like alkane or alkene. Okay. What is the reason? Why these hydrogen atom can be immediately removed by a base? Look at here. As we know that the CO group, this CO group is a polar group. CO group is a polar group. What do you mean by that? The carbon is slightly positive and oxygen is slightly negative. Now listen very carefully. Since this carbon atom is slightly positive, what will happen? This positively charged carbon will attract the bond pair of electron. They will attract this bond pair of electron towards it, because this is positively charged, so it will attract the bond pair of electron towards this carbon. Similarly, what will happen when these electrons are attracted towards this carbon, this attraction will also be there. Okay, once again, the CO group is polar in nature. That means this carbon is slightly positively charged. Due to the positive charge on this carbon, what will happen? This will attract this bond pair electron. Bond pair electron will be attracted towards this carbon. Same time, what will happen? This bond pair electron will be attracted towards this carbon, because this is moving. Again, a small positive charge is creating on this carbon. Therefore, this bond pair of electron will be attracted. This bond pair of electron will be attracted. This bond pair of electron will be attracted. If in such case, if a base is coming, suppose OH minus is coming, what will happen? OH minus will immediately remove this proton, because this bond pair electron is little bit moving away from this hydrogen. That time, if a base comes, what will happen? Base will immediately remove this proton. Clear? Once again, CO group is polar in nature. That means this carbon is having a side positive charge. Because of this positive charge, it will attract this bond pair of electron towards it. That means the entire electron, this bond pair electron will be attracted by this positively charged carbon. So when this bond pair electron is attracted towards here, that time, if a base comes, NaOH, OH minus, this is a base. When a base comes, what will happen? The base will immediately remove this proton, or this proton, or this proton. Okay. So after removing this proton, what will happen? You can see that if a proton is removed, so look at it here. In general, R, C, double bond O. Here it is a C, H, H, H. Okay. You can see that if a base, any of the proton, the base removes a proton. So what will happen? This pair of electron, after removing the proton, this pair of electron will move towards this carbon. And what we get, you can look at it here. You get an anion like this. See, R, C, double bond O, C. Here it is H, here it is H, with since a pair of electron is moving, and a pair of electron and with a negative charge, you get anion. This anion is known as enolate ion. You can see that anion, a carbon is having a lone pair electron and negative charge. This is known as enolate ion. This enolate ion can be stabilized by resonance. So, once again I repeat how enolate ion is forming. Before that, you must know that alpha hydrogen atom in carbonyl compound is acidic in nature. I think that point is clear to you. Now I explain how enolate ion is forming. You can see that here it is, if I take here it is R, C, double bond O, another C, here it is another R, here it is another R, here it is H. Anyway, this is this CO group attached carbon is alpha carbon. The hydrogen atom present on the alpha carbon is alpha. This is alpha hydrogen. Okay, alpha hydrogen. So CO alpha carbon. This is alpha hydrogen. Now a base comes. Base means B. Base OH minus, B minus. So B minus, generally B minus removes this proton. Then what will happen? This pair of electron, this bond pair electron will be shifted to carbon, and we get R, C, double bond of C, R, and this pair of electron is moving here. Here it is a negative charge. This anion, negative charge anion, this is known as enolate ion. This enolate ion can be stabilized by resonance. Look at it here, how it can be stabilized by resonance. This pair of electron will be shifted to here. Okay, and this pair of electron will move towards this oxygen. This is the resonance structure of enolate ion. Look at it here. This pair of electron is shifting to here. Then here it will become a double bond. This will be migrated to oxygen. So you get the resonance structure like this. R, C. Here it is O minus with a pair of electron, and here it will become C, double bond C, and here it is R. Okay, this is the resonance structure of enolate ion. So enolate ion has two structures. In the first case, the negative charge on the carbon atom, that means if a negative charge on the carbon atom, that is known as carbanion. This is carbanion structure, and here you can see that the negative charge on the oxygen atom, that is known as the oxyanion structure. There are two structures for enolate ion. First one is negative charge on the carbon atom, which is known as carbanion structure, and here the oxygen is the negative charge is on the oxygen atom, that is known as oxyanion structure. There are two structure for enolate ion. So enolate ion can be stabilized by resonance. Okay, this is very important. So we can see that, or in general, you can see that carbonyl compounds are slightly acidic in nature. Okay, slightly acidic in nature. Once again, I repeat, in carbonyl compound, we can see that CO group attached to carbon is alpha carbon. The hydrogen atom present on the alpha carbon is known as alpha hydrogen. Alpha hydrogen is more acidic. What do you mean by acidic? That a hydrogen atom can be immediately donated to a base. Why it can be immediately donated to a base? You can see that the CO group is polar. Therefore, the carbon is slightly positive charge. Therefore, this bond pair of electron will be attracted towards carbon. That attraction will affect this bond, and this bond. Therefore, what will happen? This bond is have a tendency to move to this carbon. That time, if a base comes, base can easily remove this proton. After removing the proton, what will happen? We get a structure like this. This bond pair electron is moving to carbon. Carbon is getting a negative charge. This anion is known as enolate ion. This enolate ion can be stabilized by resonance. That means this pair of electron is moving to here. That time this double bond, one of the bonds is moving to oxygen. You get another structure like this with the oxygen is having a negative charge. This is known as oxyanion. Okay. Actually, this both the enolate ion has two structure. One has what is one? This is carbanion structure, and this is oxyanion structure. This is known as this is the enolate ion. This enolate ion can be stabilized by resonance. Okay. This is the two structure of resonance structure of enolate ion. One is carbanion structure, and the other one is oxyanion structure. So enolate ion has two resonance structure. This point is very important. Okay, and thank you. We will continue in the next class.